Hello friends, this is Bindu Kumar here. Let's solve this question together. Which term of the arithmetic progression 3, 15, 27, 39 will be 132 more than its 54th term? So what they are saying is that this set of numbers 3, 15, 27, 39 is an arithmetic progression. They're asking which nth term of this arithmetic progression will be 132 more than its 54th term. Let's start by writing down what we can understand. So first we see the arithmetic progression itself. We see the first four numbers. So we'll write 3, 15, 27 and 39. But this is not the only set of numbers. There are more numbers. It is just that it is not given here. Next, we will assign this numbers A1, A2, A3 and A4. So now what we have to find out from this? So it is said there is a number a of n such that it is 132 more than the 54th term. So there is a of n such that it is 132 more than the 54th term. Now we do not know what is the 54th term. We do not know what is a of n. We only know the difference between a of n and the 54th term. So we have to find n also. Okay, so this is the information that we have from the question. Before we can solve this, we will first write down what are the equations we have for an arithmetic progression. So a set of numbers a1, a2, a3 and so on are said to be in arithmetic progression if they are of the form a plus d, a plus 2d and so on, where d is the common difference and d can be calculated as a of n plus 1 minus a of n. For example, d equals a3 minus a2, and this should also be equal to a2 minus a1. We also have the equation for finding out the nth term, which is a of n equals a plus n minus 1 into d. So if you look in the question, we have the value of a. The value of a is the same as a1, which is 3. But we don't know the value of d. So let's use this formula to calculate the value of d. So I'll write d equals a3 minus a2. D equals, the value of a3 is 27 and the value of a2 is 15 equals, so 27, 15, we get 7 minus 5 which is equal to 2 and 2 minus 1 which is equal to 1. So we get 2 equals 12. D equals 12. Now just to be sure, I'll calculate d once again, but this time it will be a2 minus a1. So if it is correct, I should get the same value. The value of a2 here is 15 and the value of a1 is 3. We get d equals 12. So here you can see we got the same value for d, which is the common difference. Okay, so now we have these values. We have a equal to 3 and d equals 12. Now let's use the last formula that we wrote here, right, and try to come up with an equation for a of 54. So we know A of 54 equals A plus n minus 1 into D. A of 54 equals the value of A is 3 plus the value of n is 54 minus 1 into D. D is 12. So simplifying this, we get A of 54 equals 3 plus 53 into 12. A of 54 equals 3 plus, okay, so let's multiply 53 into 12. We have 2 into 3 is equal to 6, 2 into 5 equal to 10, plus 1 into 3 is equal to 3, 1 into 5 equal to 5. So we get 6. So you get 6, 3 and 6. Let me erase that. It is 636. So A of 54 equals 639. Okay, so we will keep this on one side, and now let's write the equation for A of n. So A of n equals A plus n minus 1 into D. Now we also have from this question A of n equals A of 54 plus 132. So if you look at this equation, this is of the form A equals B and A equals C. So given A equal to B and A equal to C, we can write B equal to C. So applying this rule, we will get A plus n minus 1 into D, which is from here, equals A of 54 plus 132, which is from here. So now let's solve this. We know the value of A equal to 3, plus we do not know the value of n, so I will leave it as is. We know the value of D as 12 equals, we know the value of A 54 as 639 plus 132. Now let's simplify this. 3 plus 12n minus 12 equals, so I'll write 639 plus 132, we get 11, we get 7, we get 7, 771. Okay, I missed one important step here. So it's actually 3 plus 12n minus 12. Sorry for that. Okay, so now what I want to do is I will keep the variable which is n on one side and remove all the constants. So how can I do that? So I'll write 3 plus 12n minus 12 equals 771 equals 771. Now if I want to remove minus 12, I will add a plus 12 here, and whatever I do on the left hand side, I should do it on the right hand side as well, so that I can balance the equation. Similarly, I want to remove the plus 3 here, so I will add a minus 3 here, and the same will be repeated on the right hand side of the equation. So with this, plus 3 and minus 3 cancel out each other, plus 12 and minus 12 cancel out each other. We are left with 12n equals, so we have 77 plus 12 minus 3, which is 771 plus 9. So 12n equals, we have 780. Now here I want to remove the 12, so what we will do is we will divide by 12 on both sides of the equation. So 12 divided by 12 equals 1. We have 78. So let me divide 780 by 12. Okay, so let me try 12 into 7. Okay, so this is too much. Let me try 12 into 6, or why not take the most lowest denominator possible. So we'll start with 2. Okay, so we have 2 into 6 and 2 into 3, carry over 2 into 9 equal to 18. So we have 780 and 12 divided by 2, we get 390 by 6. Again, let's go with 2. 2 into 3 equal to 6. 2 into 1. 2 into 1 equal to 2. Then we have 18. Then we have 5. Okay, so we get 195. Then let's say 3 into 1 equal to 3. 3 into 6 equal to 18. Oops. Yes, that's correct. 3 into 6 equal to 18, and 1 carryover. We have 3 into 5 equal to 15. So I just want to confirm that. So I'll write 65 into 3. 3 into 5 equal to 15 plus 3 into 6 equal to 18. 18 plus 1 equal to 19. We get 195. So the answer for n, which is what is the nth term, or what is the value of n, is 65. Right? Thanks for watching this video. I hope you find it useful. Remember to like, subscribe, and click on the bell button to get notified of new videos.